Have you guys ever been grateful for the existence of addresses? Think about it. What if you needed to get to your friend's house and you just had a vague idea of the location? You'd get lost so easily. To properly locate the house, you'd need the street number and the house number, right? Similarly, the elements of a matrix have an address too, through which their location can be noted. You already know by now that we represent a matrix by arranging the elements of a matrix in rows and columns, and that a matrix is always represented with a capital alphabet. Here, this matrix is represented by capital A, and its elements are represented by small a. If it had been represented with capital B, its elements would have been represented with a small b. Since it's a general representation, we do not exactly know how many rows and columns are there. So, let's represent the number of rows with m and the number of columns with n. Both of course being positive integers, this makes the order of the matrix m by n. Now, all the elements of the matrix are arranged in rows and columns. This means that every element has its own unique place. As we can see, their uniqueness is mentioned by these two numbers here in the subscript. This helps us recognize the place of any element, which in this case is in the first row and the first column, while this element is in the second row and the third column, and this element is in the mth row and the nth column. So, the element of a matrix under consideration always lies at the intersection of its given row and column. And the number of rows or columns in a matrix is always a positive integer. Now, let's say I chose a random element of this matrix. This element obviously lies in some random row. Let's call it row I for now. And of course, it also lies in a random column. Let's call it column J. Thus, the location of this element can be specified by the intersection of row I and column J. This is the simple trick that helps us identify the location of any element in a given matrix. Also, keep note of two important points. Firstly, the value of I, which is the number of row in which an element lies, would never exceed the value of m, as m is the last or the limit of the rows of this matrix. So, I will always lie within m. Secondly, the value of j, which is the number of column in which an element lies, can never exceed n, as n is the last or the maximum number of the columns of this matrix, and j would always have to be within it. This means that we can also represent this element like this, specifying that an element lies in the ith row and jth column of a matrix having order m by n. Here, we can see that the element lies in row I and column j, in a matrix of the order m by n. Pretty simple, right? Again, remember, I and j cannot exceed m and n. Why don't we go over an example to get a good grip of this concept? Here, we have a matrix. Its order is 2 by 3. Now, if I ask you to identify the location of 7 in this matrix, it wouldn't be so hard, right? It is easily traceable as it lies at the intersection of the second row and the third column. Its location becomes 2, 3 or simply 2, 3. After this example, I feel like we have succeeded in recalling all the concepts related to identifying the location of an element of a given matrix. Now, whether you are friends with the elements or not, you will always be able to know where they lie and pinpoint their exact location.